Hello explorers, it's that time again. It's Advent of Code, finally! And as normal, you can join the channel as a Christmas explorer and see all the uncut content before I publish any video. Day 10, Pipe Maze. You use the hang glider to ride the hot air from desert island all the way up to the floating metal island. This island is surprisingly cold. There definitely aren't any thermals to glide on, so you leave your hang glider behind. You wander around for a while, but you don't find any people or animals. However, you do occasionally find sign points labeled hot springs, pointing in a surprisingly consistent direction. Maybe you can find someone at the hot springs and ask them where the desert machine parts are made. The landscape is alien. Even flowers and trees are made of metal. As you stop to admire some metal grass, you notice something metallic scurry away in your peripheral vision and jump into a big pipe. It doesn't look like any animal you've ever seen. If you want a better look, you'll need to get ahead of it. Scanning the area, you discover that the entire field you're standing in is densely packed with pipes. It's hard to tell at first, but because there are the same metallic silver column as the ground, you make a quick sketch of all the surfaces pipes you can see. Your puzzle input. The pipes are arranged in two-dimensional grids of tiles. A vertical pipe, a horizontal pipe, a 90-degree bend for north-east, and so on and so on. And then you have is ground. There is no pipes on this tile. S is the starting position of the animal. There is a pipe on this tile, but the stretch does not show what shape the pipe has. Based on the acoustics of the animal scurrying, you are confident that the pipe contains the animal is one large continuous loop. For example, here is a square loop of pipes. If an animal was to enter this loop at the northwest corner, the sketch would look something like this. In the above diagram, the S tile is still 90 degrees F bend. You can tell because it's adjacent pipes connecting to it. Unfortunately, there are also many pipes that aren't connected to the loop. This sketch shows the same loop as above. In the above diagram, you can still figure out which pipes form the main loop. They're connected to S pipes. Those pipes connect to those pipes. Those pipes connect to pipes. Those pipes connect to, and so on. Every pipe in the main loop connects to its two neighbors, including S, which will have exactly two pipes connecting to it, and which is assumed to connect back to those two pipes. In this sketch, it contains slightly more complex loop. The same example as the sketch with an extra non-loop pipe tiles as also shown. If you want to get out of the head of the animal, you should find the loop that is farthest from the starting position. Because the animal in the pipe doesn't make sense to measure this by direct distance. Instead, you need to find a tile that would take the longest number of steps along the loop to reach from the starting point, regardless of which way around the loop the animal went. In the first example, the square loop, you can count the distance of each tile of the loop and point. Find a single giant loop starting at S. How many stops along the loop does it take to get from the starting position to the farthest from the starting position? So I have one of the loops here. I think I will take this description here. Make something of that. vertical or north-south is a pipe. Those are the values. And then this is a 5x5 grid. So size of 5. Think all the maps are square. Let's see, the larger example I think was 5x5 as well, right? Yeah. For each line, we will split it up by the characters. We will have an int x, int y, like that. Y plus plus, and then for each character here we will have x plus plus, and then in the map at position y times size plus x we'll put c. And I think we should have a print function as well. Maybe we did a print function on like day 2 or something like that. It was fairly early in the examples here. Yeah, print map, here we have it. Let's reuse that. And we called it map size, so why not continue there? Like that. Just print the map, see what we get. There we go. So now we have the full map. Start x, 0. Start y, 0. I also think we will need to have a boolean visit. So the places we have visited, new map size times map size. If equals start, then start x equals x, start y equals to y. Visit loop length. So we will run a loop length. from start X to start Y. We will start at 0. We have the visited and the map. Create that method there. I think we need a direction as well. Like that. Print them out. So let's see. Let's get some more distance here. Now we have starting position, we have a length, we have a direction, we have the number of visits, and so on. I wonder if we need a length actually. I think we can skip that. I forgot to make these static. There we go. So now we should be able to oh, we got longs back. Fine. So in this, if the direction is north, so we come in from the north, and we take the map, start y times map size plus start x, string tile. If the tile is north-south, like that, then we will visit this tile and also if we haven't visited the tile below us, we will visit this tile that we are on, and we will turn loop length of this tile, start X, start Y, and we will have 1 plus this loop length, because this tile will also count. And we will still come in from the north, and we will need a visit, and we need a map. And this will return 0, because we can't move anymore now. So let's see, we have another tile here. We have the northeast. And in this case, when we go east, we have X plus 1. Then we will do that, but we will do that. And if we have a northwest tile, we will go -1 instead. So in this case, we come in from the east. In this case, we come in from the west. Oh, so many things to work out here. But I think I figured it out now. So let's do some debugging. So if we go north, then we have a -1, +1, seven, 0, 1, 1. Okay. So if I instead say that we return 1 for that tile as well, we'll get 8. 8 divided by 2 is 4. So that's correct. If we take a little bit more advanced example here, we get 14, which is 7. And they counted 8. And that's because we have a bunch of these where we don't have a parenthesis around them, which is terribly important. So let's go through and see that we don't have any of these kind of bugs. Only that particular case I had forgotten about it. Yes. So now it's 16, which means 8. So that is correct. So if we switch over to the full example here, and I think the map size here was 140. We got very short. Come in from the west. And come in from the east. Yes. Stack Overflow. So what we need here is pretty much new starting position and a direction, right? So in order to do this, we need a class, int x, y, action, and we also need a long count, public position int x, int y, and then we will have a get x, get y, get counts, let's increase the count, and get direction, set direction. We can also say move, public void move direction. So that will do a count plus plus. This direction would be direction. Let's make these public. Like that. If direction equals to north, north, south, we come in from the west and east. position, north P, new position, start X, start Y. As far as it can move. We'll do this loop length, north P, and then we will give it north P. South, west, east. Move. Position. North. South. West. East. There we go. There we go. The map size to 5 again. And move back to our text. Not correct. We come in from the west. East, yeah. Of course. If you do it wrong, then it is wrong. 1611. Yes? Correct? So we got this value, and we should divide that with 2. Calculator here, divided by 2. 6,823. So let's see if that is the correct value. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. You have the right answer. This video series is sponsored, so for all your hosting needs, go to DigitalOcean.
If you want to learn something new this Christmas, then you can go to Coursera, take any of those 7,000 courses over there, or follow along with the simple Java course that I provided as well. And if you want to give your kids something really great for Christmas this year, you can give them a one-on-one course with a Code Combat trainer in order to learn coding. All the links can be found in the video description.
You quickly reach the farthest point of the loop, but the animal never emerges. Maybe it's the nest within the area enclosed by the loop. You determine whether there is even worth taking the time to search for such a nest. You should calculate how many tiles are contained within the loop, for example. The above loop encloses merely 4 tiles. The 2 pairs of dot dot in the southeast and southwest marked with I below, and the middle tiles marked with O. Are not in the loop. Here is the same loop again with the regions marked. In fact, there doesn't even need to be a full tile path to outside tiles to count as an outside loop. Squeeze between pipes is also allowed. Still the loop has 0. Okay. In both of the above examples, 4 tiles are enclosed by the loop. Here's a larger example. There are just tiles that are enclosed in the loop, marked as I. There are 10 tiles. How many tiles are enclosed by the loop? Oh, Jesus. I think I need a break. And we are back. And I've been thinking about it, and as I'm not a scientist, not a mathematician, I'm a pragmatic coder. So we know now that the loop that we're interested in is the west loop. That is the one that we actually are running. So if we skip the first loops and the last loop here, so we only have the west loop to run, we should get the same result. Yes. And we should be able to use our print map down here, but we can print it with the visited map as well. So if the visited map, if this is true, then we will print the other one so you can actually see how this loop looks. And maybe we can figure something out there, or just count. That could be a very pragmatic solution to this kind of problem. Yeah, this should of course be here instead. So, if we run this, oh, we got that kind of thing. That's no good. Else, we will print dots. See how this looks. And I'm back, and I have a value now. And this is using what you know, using the libraries that are available to you, and not really doing a bunch of math or other things. This is the pragmatic approach. So we had this west loop. We know that that encompasses the whole loop. It gets the correct value out. And then I have something here where I calculate the area. How do I calculate the area? Well, in this case, I have this loop length. Let's go back. We have this position. And we have a couple of things. First, we have the position where we actually start the position at XY. And I have created a general path here, which is a part of the Java library. The AVT, the drawing library, so we can create a path where you draw things. And I start that at XY. And then every time I do a move, I draw a line in this general path. And when I can't move anymore, I close the path. Then, when I want to calculate the area, I can go through this map and I can get the bounds. Could use that just to get a smaller map to go through. But I go through the full map. And then if I have visited this point, I don't count it at all. I don't care about it. And if I haven't visited, I check if this current path contains this XY value, which is that it's inside of it. Then I will add to the area. And then I got this value, 416. So let's see if that is the right value. I'm hopeful this got it right with this. It got 10 tiles with this complicated one. No, your answer is too high. Not good, not good. Again, maybe I just did a little bug in the beginning, and maybe I was very close to the solution. I now got 415, which is one lower than 416. And the reason I got one lower is just because when I ran this, what I do is go through all these and loop through them with a position, but I move to the next. And when I move to the next, it's not before I actually loop in here that I actually set the tile that have been visited. So the first position that I start on is never visited. So now I set that to true as well after I done the full loop. So that means that I actually have visited all the places. And then I got 415 in this crazy loop. And I also did a printout as well, so to see all the squares that were in this. So they look reasonable. So let's try with 415. Yes! You get a gold star, I get a gold star, everybody gets a gold star. So it was just a bug. It was just a bug. Oh my god, it took me so long to find that bug. But we are pragmatic and we are using built-in Java functionality, standing on the shoulders of giants in order to figure out what the area of this crazy maze is. I hope that you liked this video. Give it a like, share it with your friends and colleagues. If you solved it in a better way or another way with just Java code or just code, put that in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.